So, you've probably gotten pretty good at prompt engineering, right? Well, what if I told you that's kind of yesterday's news? The skill that built today's AI is already evolving into something much more complex. Today, we're diving into its successor, a discipline that's fast becoming the single most important skill for building the next generation of AI: context engineering. So, what's the big deal? Well, let's look at this. On the left, you've got a simple prompt. It's a single command like summarize this article, and you get a single output. Easy enough. But on the right, you have a goal. Booking a flight isn't a one-shot deal. It's a whole project that needs planning, using tools, and making decisions. This is the massive leap from simple chatbots to what we call autonomous AI agents. So, what exactly are these agents? You got to think of them as way more than just chatbots. They're more like autonomous little programs. They use a large language model as their brain, for sure, but they also combine it with tools, with knowledge, and with memory to get complex jobs done all by themselves. To pull off something like booking a flight, the agent has to take multiple turns or steps. First, it has to understand the goal and make a plan. Then, it might use a tool, call out to an Expedia API to actually search for flights. After it gets the results, it has to analyze them to find the cheapest option, and then it takes the final step to book it. Every single step is like a new thought, a new call to its LLM brain. Now, here's where it gets really interesting. With every single one of those turns, the agent is adding more information to its working memory. The results of the flight search, the decision it just made, your original request, it all gets crammed into this temporary space called the context. This context is basically how the agent remembers what it's doing from one second to the next. But this whole process, this building up of memory step by step, well, it creates a huge vulnerability. It leads us straight to the number one challenge of building powerful agents. What happens when that short-term memory just overflows? See, this short-term memory is super fast, but it's also super limited. With every step the agent takes, it fills up more and more of that space. And if a task gets too complicated, you're going to risk a context overflow. That's where the agent literally runs out of memory, forgets what it was supposed to be doing, and just fails. And the problem is actually way bigger than just running out of room. A bloated, overstuffed context leads to all sorts of critical failures. You can get context distraction, where the agent gets totally fixated on some unimportant detail from 10 steps ago, or context clash, where new information comes in that contradicts its original goal and it just gets confused. Basically, the agent gets overwhelmed and starts making dumb mistakes. So how in the world do you manage this incredibly fragile but absolutely vital AI memory? Well, the solution is a whole new discipline, one that's becoming the bedrock for building any kind of reliable AI agent. This whole idea of active memory management has a name: context engineering. The AI researcher Andrej Karpathy put it perfectly. He called it the art and science of filling the context window with just the right information for the next step. And, crucially, nothing more. Okay, here's the best way to make this crystal clear. Think of the large language model as your computer's CPU. It's the powerful brain doing all the heavy lifting, all the thinking. The context window, then, is its RAM, that super fast but limited short-term memory it uses for whatever task is right in front of it. So, context engineering? It's literally just RAM management for AI. Now that we get the concept, let's check out the 4 main strategies that engineers are using to manage that precious RAM and keep their AI agents sharp, focused, and on track. First up is compression. This one's the most intuitive. As the conversation or the task history gets longer and longer, the agent can be programmed to just go back and summarize what's happened so far. It keeps only the key moments and decisions, effectively squishing the past to make more room for the future. The second strategy is called writing and selecting. This is cool. The agent uses an external scratch pad. Think of it like a notepad or an external hard drive. It can write down important details that it thinks it might need later, which frees up its active memory. Then, when that piece of information becomes relevant again, it selectively pulls just that one piece back into its context. The third strategy is isolation. This is really clever. Instead of giving one gigantic task to a single, monolithic agent, you break the task down and you give the smaller pieces to a whole team of specialist agents. Each specialist only needs a tiny, super focused context to do its one little job, which dramatically reduces the risk of it getting confused or overflowing its memory. So let's just put it all together. These strategies basically fall into 2 camps, right? Some, like compression and using a scratch pad, focus on making the context itself more efficient. And others, like isolation, cleverly avoid the problem altogether by just keeping the context small from the very beginning. The goal for all of them is the same: help an AI think clearly.
Okay, let's zoom out for a second. This is so much more than just a bunch of clever engineering tricks. Mastering these techniques is, no joke, quickly becoming one of the most critical skills for anyone working on the future of AI.
And that's not me exaggerating. The team behind Devin, the world's first AI software engineer, they put it this bluntly. They called context engineering the #1 skill for building capable AI agents. For them, it is not a nice to have, it's an absolute must have. What makes it so valuable, and honestly so difficult, is that it's both a science and an art. The science part is about using the right tools, structuring your data properly, and giving the AI good examples. But the art? That's the intuition. It's what some people call understanding the LLM psychology, just knowing precisely which piece of information is going to guide the AI to the best next move, when there are no fixed rules to follow. At the end of the day, context engineering isn't just about making AI cheaper or faster. It's about making it a more focused, more reliable, and ultimately, a more intelligent partner for us. How we manage an AI's memory, curating what it thinks about from moment to moment, is what will truly define its power. And that leaves us with a huge question. As we get better and better at this, what incredible new abilities are we about to unlock next?